Everyone, so now we move to our next basic geometry for 2D computer animation, and for this time around we will look into scaling. So for the scaling, not normally, but scaling can be used to change the size of an object. So this operation is carried out by multiplying a coordinate value with a scaling factor respectively. So the scaling equation or the scaling transformation can be obtained as this. Okay, we want to find our new x position, so we multiply the x all with the scaling factor. Same goes to our y new position. So scaling is performed about the origin. If the scaling factor for the x and y are 1, then the object size is remain unchanged. If it is greater than 1, if it is greater than 1, then the size will enlarge and move it away from the origin. If it is smaller than 1, then the size object will be reducing and move towards the origin. Alright. If let's say the x and y value both scaling factor give a different value, then if let's say the x is greater than 1, then in terms of x-axis it will be enlarged, and if the y smaller than 1, then in y direction we can see that the object size will be reduced. Alright, so this scaling factor also can be presented in the transformation matrix as this. Okay, hence the equation 3 can be written as this matrix. Alright, so if let's say the scaling factor occur at the fixed point xf yf, then the position of the x prime, it will be calculated as this. Same goes to the y prime. Alright. Okay, so now this is our example here, the exercise here. So if let's say I'm giving you a square with a bottom left with a coordinate 2, 2 and the right top is 6, 6, then apply the transformation which makes the size half about the origin 0, 0. So in this example here, we are applying the scaling at the origin 0, 0. Okay, so if you draw this square, you will get as in this picture here. Alright, so in this case, because our transformation factor is half, which is the 0.5 and 0.5, then we will assume that this square here will become smaller. Alright, okay, so how to apply this? We can use the equation number 3, or you also can use the transformation matrix. So if you are using the transformation matrix, remember the matrix, the first matrix here, you will have your sx, sy. So your sx is 0.5, your sy is 0.5, and then remember you have 4 coordinates here, so you will arrange like this. This is for the first point, this is for the second point, third point, and fourth point, or A, B, C, D. Then you multiply this matrix, then you will get as this one. So this is the first answer example here is I'm showing to you how to solve in matrix form. Alright, and this one is the second one on your right here is by using the equation number 3. Alright, so what happen if let's say we have a fixed point? So in this case, we have a triangle with these vertices, but then I want the the position, sorry, the 5 to the point C to be fixed, and then it must be a scale twice. So the SX, SY is twice 2, and then our fixed point is 5 2. So you need to use the equation here. Alright, equation in slide number 21. So when you apply it, then you will get the coordinate for the new position for this triangle after we scale it to twice while keeping the point C. Alright, so the scale happens at this point C. Okay.